Okay, Wildcats, today we're going to journal page 73, Graphing Polynomials Part 2. Finding the rational root steps. Step 1. Use the rational root theorem to identify possible rational roots. The rational root theorem states that if the polynomial p of x has integer coefficients, then every rational root of the polynomial equation p of x equals 0 can be written in the form p divided by q, where p is a factor of the constant term of p of x, and q is a factor of the leading coefficient of p of x. Step 2. Test possible rational roots using synthetic division. Refer to page 27 for synthetic division notes. Step 3. Repeat synthetic division to the new function until it has a quadratic function ax squared plus bx plus c. Step 4. Once it is in quadratic form, either factor or use a quadratic formula. Alright, if you would, complete the notes. Alright, now your notes are complete. Let's take a look at the examples. Alright, find the following information for each polynomial, then sketch a graph. The degree name is a cubic. The leading coefficient is 1. Number of turns is 3 minus 1, which equals 2. It is an odd degree. Now, for the y-intercept, that's when the x value is 0. Okay, so before we do that, though, we need to set everything to the left side or right side. So in this case, we're going to subtract 24 from both sides. So we now have x cubed plus 3x squared minus 10x minus 24 equal to 0. So now we're going to substitute 0 in for x. So y equals 0 cubed plus 3 times 0 squared minus 10 times 0 minus 24. Well, that equals negative 24. So your y-intercept is 0, negative 24. So at that point, you want to add that to your graph. So your y-intercept is at negative 24. Okay, now we need to identify the zeros. Well, the first thing we want to do is see if this is factorable. So we have x cubed. And actually, let's go ahead and start factoring now. We have 4 terms, so we know we can factor by grouping. So we can factor out an x squared here, which leaves x plus 3. And in here, it looks like we can factor out a negative 2, which leaves 5x plus 12 equal to 0. Now, when factoring by grouping, these have to be the same. Since they're not the same, we can say that this is not factorable. Okay? Now, when it's not factorable, you need to use the rational root theorem. Okay? So we need to find p divided by q. So we need to find all of the factors of negative 24. Well, that's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. 5 doesn't work, plus or minus 6. 7 doesn't work, plus or minus 8. And then plus or minus 12 and plus or minus 24. And then the factors of q are easy. It's just 1, so plus or minus 1. Now we need to divide all of p divided by q. Well, that's simple because you're dividing everything by 1. So you just have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. All right, now at this point, we need to use synthetic division to find the roots. So we have 1, 3, negative 10, negative 24. And let's try the first. Let's try positive 1. Okay. So now we bring down the 1. 1 times 1 is 1. Oh. So 3 and 1 is 4. 1 times 4 is 4. Negative 10 and 4 is negative 6. 1 and negative 6 is negative 6. That combines to be negative 30. Now, if this was a 0 or root, the remainder would be 0. So 1 is not a 0 or root. So now let's try negative 1. And we're going to need to go through all of these until we get 0. So we do plus 1 and minus 1, plus 2 then minus 2. And again, we're going to keep going until we get a remainder of 0. Okay, so now bring down the 1. And you're probably going to want to write light here because you're going to erase every time until you get it. So now negative 1 times 1 is negative 1. 3 minus 1 is 2. Negative 1 and 2 is negative 2. Negative 10 and negative 2 is negative 12. Negative 1 and negative 12 is a positive 12. You have a remainder of negative 12. Not 0, so those negative 1 is not a root. Okay, so now we're going to try positive 2. Okay, so bring down the 1. 2 times 1 is 2. 3 and 2 is 5. 5 times 2 is 10. Negative 10 and 10 is 0. 2 times 0 is 0. Remainder of negative 24. Again, not 0, so not a root. Okay. All right. Now let's try negative 2. So bring down the 1. Negative 2 times 1 is negative 2. 3 minus 2 is 1. Negative 2 times 1 is negative 2. That combines to be negative 12. Negative 2 and negative 12 is positive 24. So the remainder is 0. So we now have one of the roots, which is negative 2. Okay, so let's go ahead and add that to our graph, negative 2. Okay, now this was x cubed. Now this becomes 1x squared plus 1x minus 12 equals 0. It's in quadratic form, so at that point we're going to try to factor, and if it doesn't factor, we'll use a quadratic formula. Okay, so parentheses equals 0. We know x and x makes x squared. Now we have to think about what combination makes negative 12 and combines to be positive 1. Okay. Well, to answer that, that's a plus 4 and a minus 3. Because 4 times negative 3 is negative 12. 4 minus 3 is 1. Now we set these equal to 0. So x plus 4 equal to 0. X minus 3 equal to 0. So x equals negative 4 and x equals 3. So we have negative 4, 0 and 3, 0. Okay, so let's add the negative 4 and let's add the 3. And again, because you're just sketching the graph, you don't have to put negative 4, 0, negative 2, 0. You can just put the x value of the 0. Okay. Now we know that since it's the leading coefficient is positive, it's opening upwards. So we know as x approaches negative infinity, so it's going this way, f of x approaches negative infinity. And then as x approaches positive infinity, we know that f of x approaches positive infinity. So basically, when it goes left, it goes down. When it goes right, it goes up. Okay? Now, we know it has two turns, so it has to go up through here. There's one turn, it's going to go down, and it has to go to that point and turn up there. All right? If you would, go ahead and finish up example 1. Let me see if I can adjust the lighting a little bit. Okay. Now let's take a look at example 2. Okay. Now the degree name is quartic. The leading coefficient is 4. Number of turns is 4 minus 1, which is 3. It's an even degree. The y-intercept, so we know that when it's a y-intercept, x is 0. So we're going to substitute 0 in for x and solve for y. So y equals 4 times 0 to the 4th minus 21 times 0 cubed plus 18 times 0 squared plus 19 times 0 minus 6 equals negative 6. So your y-intercept is 0, negative 6, so we want to graph that here. All right, now to identify the zeros, okay, we need to see if we can factor this. Now you notice 1, 2, 3, 4, 5 has 5 terms, so we already know that it's not factorable. And you can write not factorable or just write NF, okay? All right, so now we need to do P divided by Q. So we need to find all the factors of negative 6. Well, we know that's plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. When we mean factors, we mean all the numbers that divide into 6 evenly. Okay? And then Q would be plus or minus 1, plus or minus 2, and plus or minus 4. Now we need to find P divided by Q. So we need to divide everything by 1, so that's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. But now we need to divide everything by 2. So 1 divided by 2 is plus or minus 1 divided by 2. 2 divided by 2 is just 1, which we already have. And then 3 divided by 2, so plus or minus 3 divided by 2. And then 6 divided by 2 is 3, which we already have. So now we need to move to 4. So that's plus or minus 1/4. And then 2 divided by 4 is 1/2, which we already have. And then 3 divided by 4, so plus or minus 3 divided by 4. And then 6 divided by 4, which is 3 divided by 2, which we already have. You don't want to repeat your factors, okay? Let me rewrite this so it's a little clearer. Plus or minus 3 divided by 4, okay? Now, we need to find out which one of these is a 0, okay? So we're going to use synthetic division. So we have 4, negative 21, 18, 19, negative 6. Now, I could have you try every single one till you find the 0, but that could take a long time and a lot of space. So I'm going to allow you to, on the assignment and on the test, to find the first one and then use synthetic division. So to do that, what we're going to do is new document, no, add graph. Okay, so we're going to graph this. So 4x to the fourth minus 21x cubed plus 18x squared plus 19x minus 6. Okay, so you can see here that positive 2 is an exact 0. Okay, so we know if we use synthetic division for positive 2, we will get a 0. Okay, so let's do that. Now you can see that the other zeros are going to be decimals. So the fact of it being factorable is probably not going to work. So we're probably going to want to go to the quadratic form when we get down to x squared. But let's start with 2. Okay. Now we know 2 is going to work because we know it is a 0. So we're going to bring down the 4. 2 times 4 is 8. And then negative 21 and 8 is negative 13. Okay. 2 times negative 13 is negative 26. 18 and negative 26 is negative 8. 2 times negative 8 is negative 16. It's combined to be 3. And then 2 times 3 is 6. So that is 0. Okay. Now, we were at x to the fourth. Now we're at x cubed. We're going to have to do synthetic division again, okay, to get it down to x squared. So let's find another one of the zeros. Okay. Now, it looks like we have that negative right there, which almost looks like negative 3/4. So let's try that. Okay. The other ones are harder to see what they are. That might, yeah. So let's try negative 3/4. Okay. All right. So again, we're going to use synthetic division again. So negative 3 divided by 4. So notice I've left a line space so we can do synthetic division. Okay. So bring down the 4. So negative 3 times 4 is negative 3. That combines to be negative 16. Now, negative 3/4 times negative 16, let's just go ahead and use a calculator. So negative 3 divided by 4 times negative 16 is positive 12. Negative 8 and 12 is combined to be 4. Well, this is easy. Negative 3/4 times 4 is negative 3. So the remainder is 0. Now, I forgot to, and you might, but that's okay. Once you find the 0, let's go ahead and list it and graph it. So let's go back. We have 2, 0. We know that. Okay. And now we know that negative 3/4 is another 0. So negative 3 divided by 4, comma 0. Okay. Now we know, because it's quartic, we know we're going to have 4 zeros. Okay. Now we know that this was x to the fourth. Now it's x cubed. Now this is x squared. So we have 4x squared minus 16x plus 4 equals 0. Okay. Now, what we can do is we can divide each of the terms by 4. So we can basically factor out a 4, which leaves 4 times 1x squared minus 4x plus 1 equals 0. Now to find out if this is factorable, we need to find all the combinations multiplied by 1 and combine to be negative 4. Well, we just know that doesn't work. There's no numbers that multiply to become 1 and combine to be negative 4. So this is not factorable. Now you can divide the 4 out, okay, which would just basically leave x squared minus 4x plus 1, okay? Save space, so we're not going to do that work, but we're going to basically use here to use a quadratic form. So x equals negative b, which is a negative 4, plus or minus the square root of negative 4 squared minus 4 times 1 times 1 divided by 2 times 1. Okay? So, let's go and use our calculator. So, control divide, negative 4, plus control square root. We know negative 4 squared is 16. Okay? Minus 4 times 1 is just 4 divided by 2. Okay? So, one of our zeros, and we're going to use one decimal place. So, 3.7 comma 0. And then I'm going to highlight, enter, change the plus to a minus, and then that 6 rounds the 2 up to 3, so that's 0.3 comma 0. Okay, so we know we have 0.3 right here. Graph is getting very crowded, and then 3.7 here. Okay, now we know because a coefficient is positive, that opens upwards. That means for end behavior, as x approaches negative infinity, meaning going left, f of x approaches positive infinity because it's going up. Now as x approaches positive infinity, meaning it's going right, f of x approaches positive infinity, meaning it goes up. Now we know it has 3 turns, so it's going to go here. And we know it has to go back up. So it's 1. That has to go back down to go to there. 2. And then it has to turn back up to there for 3. Okay, go and finish up example 2. Okay, let's go look at example 3. All right, degree name. We know it's cubic. The leading coefficient is negative 2. Number of turns is 2. It's an odd degree. The y-intercept we know is when x is 0. So y equals negative 2 times 0 cubed minus 12 times 0 squared plus 30 times 0 plus 200. Well, we know that that's 0, 0, 0 and equals 200. So our y-intercept is 0, 200. Again, because we're just sketching, we can put a dot here and put 200 for our y-intercept. Okay. Now, we want to see if it's factorable, so we have 1, 2, 3, 4 terms, so we're going to factor by grouping. We can factor out a negative 2x squared, and that leaves x plus 6. And it looks like we can factor out a 10 from here, so that's plus 10, which leaves 3x plus 20. These aren't the same, so we know it's not factorable. And so now we need to do p divided by q. Okay, so now we know. Now here's the thing. We basically don't want to use these numbers because that's a lot. But what we can do is we can divide everything by negative 2. Okay. If we do that, that'd be negative 2 divided by negative 2 is 1 x cubed. Negative 12 divided by negative 2 is plus 6 x squared. $30 divided by negative 2 is minus 15x. And then 200 divided by negative 2 is a negative 100. And the reason we're going to do that is because now that decreases the number of factors of p and q. Okay, so we need to find the factors of p first, which are plus or minus 1, plus or minus 2, because we're looking at all the numbers divided into 100. 3 doesn't work. 4, so plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20, plus or minus 25, and plus or minus 50. Okay. You could write 100, but really, I think we can stop at 50. And then Q is plus or minus 1. Okay. Now, we're going to need to divide all of these by 1. So P divided by Q equals, well, everything divided by 1 is itself. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20, plus or minus 25, and plus or minus 50. Okay, so now we're going to use synthetic division, and we're going to use it on this. Okay, so that's 1, 6, negative 15, negative 100. All right, and again, what we're going to do is save ourselves some time. Instead of going through all, I'm going to let you use a calculator to find the 0 and then use synthetic division. Okay, so we're going to go to on, new document, no, add graph. And so then we're going to actually go back and graph the original function. Okay, so negative 2x. Actually, let's play it safe. Let's graph everything divided by negative 2. So x cubed plus 6x squared minus 15x minus 100. Now, out of curiosity, let's actually graph the original and see what happens. So tab negative 2x cubed minus 12x squared plus 30x plus 200. So you see it's slightly different, but they still have the 0 at 5. Okay, and they still have, they still have the 0 at negative 1, 2, 3, 4, 5, negative 5. And they have 0 at 1, 2, 3, 4. Okay, now let's go ahead and use negative 5 for our synthetic division. Okay, so negative 5. So bring down the 1. Negative 5 times 1 is negative 5. 6 minus 5 is 1. Negative 5 times 1 is negative 5. Combines to be negative 20. Negative 5 times negative 20 is a positive 100. So the remainder is 0. So we know that this is a 0. Negative 5, comma 0. Okay. So let's go ahead and graph that there. Okay. Now we know that we were at x cubed, now we're at x squared. So 1x squared plus 1x minus 20 equals 0. And let's see if it's factorable. We know x and x. And we think about what numbers multiply give you negative 20. Well, that's easy. Plus 5 minus 4. Because 5 times negative 4 is negative 20. 5 minus 4 is 1. So you have x plus 5 equals 0. X minus 4 equals 0. So x equals negative 5 and x equals 4. Okay. So we have -5, 0, 4, 0, and we can't forget about this, -5, 0. So basically what you have here is -5 occurs twice. So we'd say that x equals -5, and we would actually say that's a multiplicity of 2. And then x equals 4. Okay? All right, so we have -5, we have +4. Now, we're going to go back to the original graph because that's what we're asked to graph, not what was divided by 2. Now, the negative means it opens downward. Okay, now we know that there are 2 turns. Okay. Oh, wait, almost made a mistake. And that's why we want to be careful. What I did was I was thinking about Quadratic Form, and I forgot that it was cubed. Okay, so that means that it opens upwards here and decreases there. So you want to be careful when graphing, and what you might do is after you're done, you can go back and check your calculator to check your work. And so this verifies that I've corrected my graph. Okay. Now, when it's multiplicity of 2, it touches and turns. Okay. So then it goes to here and it turns there. Okay. And behavior. So as x approaches -infinity, meaning we go left, f of x approaches +infinity. Now, as x approaches +infinity, f of x approaches -infinity, meaning it goes down. All right, if you would, go ahead and finish up your examples, start working on your assignment, and have a wonderful Wildcat day.